What's up, good people? My name is Farai and welcome to yet another video on your channel Magetsi 2.0, your go-to channel for all things electrical. Now in today's video we're going to go through how we can implement the direct online motor starter to protect a single phase motor. Now this should be an easy thing to do, but the only part that makes this tricky is the overload relay. Now overload relays generally come in 3 phases, and I can tell you this for a fact that in my entire trade career as an electrician, I've never come across a single phase overload relay complete with normally closed contacts just like what we find on 3-phase overload relays. But not to say that they don't exist, but I've never seen one. But not having single phase overload relays shouldn't be a train smash, because we can still implement the same 3-phase overload relays to protect our single phase motors. But we just have to make a few adjustments to our wiring. Now there are 2 basic wiring methods that we can implement to execute this method flawlessly. But before we go through those wiring methods, let's lay some important groundwork. Overload relays rely on the thermal component of current flowing through a conductor in order for them to be able to detect overloads. So for overload relays to function properly, all the 3 poles have to be populated and current has to flow through each pole. Now this is because we don't want any nuisance tripping situations. And also bear in mind that some overload relays have phase loss protection, so not populating 1 or 2 of the phases on the overload will be interpreted as phase loss or single phasing. That's another nuisance tripping situation again. And also, compared to its 3-phase equivalent, a single phase motor will run on a voltage that is 1 over square root of 3 of that of the 3-phase voltage. Now, since power is voltage multiplied by current, then current in a single phase motor should be more. It becomes root 3 multiplied by the 3-phase current. So for example, if a 1.1 kilowatt motor draws say 2.5 amps running at 380 volts, so we expect its single phase equivalent to draw roughly square root of 3 multiplied by 2.5 amps, which gives us a current that is around 4.3 amps at 220 volts. Now, due to this issue, you have to select a contactor size that can handle the starting currents associated with the single phase motor, as the full load current has increased by over 73%. Now remember, square root of 3 is approximately 1.73. So you also need to select an overload relay that is able to protect your single phase motor. Now, control voltage will depend on how your system is going to run. If you are integrating your starter into existing controls, then be sure to select a contactor coil voltage that matches what's already there. But if it's a standalone or brand new system, then the easiest thing to do is to go with your single phase voltage, say 220 volts control. That will help you eliminate the control circuit breaker unless you really need it. So after taking into account all these factors, then you have to decide which method you are going to use for wiring up the power circuit of your single phase induction motor. And as we've mentioned before, there are two basic methods for wiring up the power circuit. And I've came up with names to help you remember these methods. But before we go through these methods, this video, I assume that you already know your way around a direct online motor starter control wiring. And if you still don't know about the direct online motor starter control wiring, then you will have to watch this video, which gives you all the fundamentals of a direct online motor starter. So these two methods that we use for wiring up the power circuit of a single phase induction motor are the loop back method and the loop through method. These are the names that I came up with so that I can help you remember these methods. Now, the first method that we are going to go through is the loop back method. So in the loop back method, all the current carrying conductors, in this case the live conductor and the neutral conductor, are wired through both the contactor and the overload relay. Now, to ensure that all three poles of the overload and contactor are populated, one of the current carrying conductors loops back, as in the name, so it can populate the third pole. This ensures the current that flows through all the overload contacts is the same. Now, the advantage with the loop back method is that your contactor switches both the live and the neutral supplies. So if your motor is turned off, your load is completely isolated from the supply. So there's no need for a double pole circuit breaker. The only thing that I have against this method is the cable which loops back to the top of the contactor. It's not much of a big deal, but I hate wires feeding back current to the top of the contactor like this. But apart from that, this method is perfectly fine and is all yours to use. Now let's examine the loop through method. Now with this method, only the live conductor loops through all three contacts of the contactor and the overload relay. Now, because one leg won't be switched by the contactor, typically the neutral, then I would suggest using a double pole breaker for total isolation of the supply. Or you could use an isolator in conjunction with your starter circuit. Now, what I like about this method is that you only have one current carrying conductor looping through the contactor and overload, so there's no risk of mixing wires of different voltages here. Now, the downside of this method is that the neutral is not switched through the contactor, but that's not a big deal as long as we have proper operation of our overload. And you can always use a double pole circuit breaker to totally isolate your circuit. So there it is, guys. So next time a client chucks a single phase motor at you without a control box, just tell them, I got this, and then implement that direct online motor starter for that single phase motor like a pro. All right, as you saw, the motor that I was using, this induction motor that I was using for this exercise, is not a single phase motor, but this is my old trusted 3-phase electric motor that I've converted to run on a single phase supply. So in our next video, we're going to go through the conversion process of running a 3-phase electric motor using a single phase supply by use of a run capacitor. So make sure not to miss our next video. So until next time, people, tonana.
Isai mawoko woye, Isai mawoko joda kutenda misha woye, misha woye, misha woye, misha.